Okay, it is now 9 o'clock and we will get started right on time. Thank you all of you for joining us today. For those of you that are familiar with PROergonomics webinar series, we do a free webinar every month on a variety of topics. It's kind of our way of trying to give back and educate and, kind of empower people and corporations into making, hopefully, positive direction moves in the word or name of ergonomics. For those of you that are not familiar with PROergonomics and are new to us, well, thank you for joining. And we are a health, safety, and ergonomics consulting firm, and we try to help people by reducing injuries, saving them money, and bring up efficiencies if we can. So in the name of today's topic, and give me a second, I apologize. There seems to be a little bit of glitching. There we go. So in the name of today's topic, adjustability on the line, my name is Alexandra Stinson, or Alex, for those of you that know me, and have been doing ergonomics for over 20 years, and I would say the area that actually spurs the most conversation is definitely that manufacturing industrial type setting where we have really quick changeover on equipment and technology and innovation, and we're always looking to find a better match, but we also need to sustain and achieve kind of the primary production goal so that we can obviously have a company that's healthy and hardy and going to continue on into the future. So ergonomics can sometimes be easy because sometimes the elements are fast-paced and changing, and sometimes we hit walls. And adjustability on the line obviously is not going to be something that we can easily do. We can't have a line that goes up and down for each individual person. And so when we get into that design phase and we hit this wall, there is a tendency for us to kind of step back and say, oh, there's nothing we can do about it. And this session is really going to try and challenge you and encourage you to maybe just look at other areas where we could find adjustability so that we can't get stuck on the fact that people are working at improper heights, but not thinking that there's nothing we can do about it. So for the topic of today's, the agenda, we will be going through kind of the effects of poor design. We'll look at designing for ergonomics. What are our ideal working heights? Who should we be designing for, which is often a funny question, and we'll get lots of different, we actually get lots of the same answers, but they're not necessarily the right ones. And we will be touching on some possible solutions for some of our main kind of hitting areas. So with further ado, we will just jump right in. Generally speaking, our main body parts that we're going to see discomfort or high injury ratings when attributing to poor design are definitely going to be shoulder, definitely going to be back, potentially neck, and our wrists, oddly enough. So when we look at the effects of maybe designing at one stationary height or one specific height, typically we kind of go for just a standard number, and that's only going to accommodate a very small portion or percentage of our workforce population, which results in, on the left, our smaller employees reaching up, which can cause impact to the shoulders, potentially the neck if it's that high. Hopefully it's not that high if it's a working height. And we get that bent wrist. So our wrist will start to bend forward, trying to kind of achieve physical dexterity at a height that's maybe higher than what we ideally like. For those of us that fall on the taller side of the spectrum, we now have stooping and bending forward. So we get that, looking down at the item that we're trying to work on, the stooping up the back. And then we also get the bent wrist, but we get it in the opposite direction. We'll start to see wrist extension come into play when we start dropping working heights that are too low for an individual. So what we're always trying to achieve is this version on the right, which is going to have our workers, standing or sitting, I guess as the case may be, but with alignment throughout their torso. So the spine has a natural S-curve alignment. We do have a bit of awkward posture at the elbow, but research has shown that that is not a posture that is not sustainable for us as human beings. So we're not so bad there. And then you can see that that wrist posture becomes straight. So going forward, elbow height becomes a really key, kind of crucial working height to remember, because it is the only height that's really going to achieve all three of those kind of good posture points. So if you kind of right now bend your arms to 90 degrees, you can see that this is really the only part where, yes, you can sit upright, you're not reaching forward for anything, but you're also getting that perfectly straight wrist, which as soon as you start moving that working height, we don't achieve that anymore. So that's a key one that we often will forget about, because people go for the bigger muscle groups, the shoulder and back, and we forget that there's a negative impact at the wrist as well. So we're going to talk just briefly about anthropometrics. So anthropometrics, for in a glib version, shall I say, is basically your average statistical parabolic curve. We do have two of them. We have our female tables, which you'll see on the left, which are generally smaller, and we have our male tables on the right, which are generally slightly higher. So if we were to have our heights kind of along the left axis, and our percentage of the population kind of along the bottom, you'll start to see that a bulk of our design is really focused on, sorry, we have the female tables, the male tables, but the bulk of our design is focused in this central section. So that 5'6" to 5'10" is really where, if you open up a catalog, or even, even if we are designing things, but it's kind of the design pinpoint for a lot of our engineers and our design teams, and it is at 5'6" to 5'10". So if you start thinking about, okay, well, where am I on that spectrum? Are you 5'6" to 5'10"? Because if you're not, then you are one of those individuals that is going to have a compromise in your posture. So what we'll start to see then is we then have these two areas of or working population that are not being designed for, and that are demonstrating the awkward postures that we showed in the slide above. This is not ideal. This is not ergonomics working at its best to say, okay, well, we've captured the average person, then we're good, because that's not what our workforce looks like. Our workforce looks potentially varied. Maybe your workforce doesn't look varied, but is skewed maybe to the smaller. Maybe you have racial demographics that, where the stature is typically smaller than North American to anthropometrics, and therefore you're skewing a little bit to the left, or vice versa, a little bit to the right. But either way, anytime we start thinking that it is okay to design for the average, we know we're also saying that injury is acceptable for those that are smaller or taller, because we are going to be forcing them to work in postures that are not going to be ideal. So when we go through this, we then kind of want to ask ourselves, how do I design for more than just this average? And before I think we can answer that question, we need to know, are we even designing for the average correctly? And often I have seen clients where, you can tell going in and doing my assessments that there has been thought and strategy behind how they've designed the line. However, they did not take it to the end goal place because of a couple of areas that just maybe weren't considered, or they didn't know at the time and they just moved forward. So one of the things that we will do quite frequently, and it's something we absolutely adore doing, because from a cost perspective and an efficiency perspective, design reviews is really where we can save costs and save injuries to the highest level possible. And so when we're looking at designing correctly, we need to figure out, first off, what is our base height? And there's a couple of questions we can ask ourselves. First off, we need to understand, what type of work are you doing in your facility? Is it precision work? Are we doing, fine wiring work or fine, microchip assembly, that type of thing, where we're using very tiny things and we want to, be able to see really well? Are we doing kind of light to moderate assembly line type work where we're kind of dealing with a lot of forces and weights, in and around the 12 and under pound mark? Or are we having some work that's being done that is quite heavy? So that is the first question we need to ask. So as you're going through, mentally check off one of those boxes. Where do you fit in your organization? And then we need to kind of go from there. So we're not done. Just defining the type of work is a starting point. And most people feel that they belong in the light to moderate work, but not all places along the line may have that. For instance, let's say on an automotive car assembly line, we have a lot of light to moderate work. We also have 2 or 3 jobs that are heavy, and we also may have 2 or 3 jobs that are precision. So you start to see the challenges we have right off the bat. So again, we're going to design for the average, we're going to design for the light to moderate, and the precision and heavy may be sacrificed to some degree. So we then get into the next question, which is, what is the equipment height? And one of the best examples I saw where you could tell they had spent a lot of time trying to design their line, with ergonomics in mind. And they had decided which, line they were going to be working on. And then they jumped actually to the last question, which is, what is the product height? And they took that into consideration. So when you walked in, if nothing was on the line looked ridiculously low. And you would have been thinking, what are they thinking? But as soon as the part and product came onto the line, it was a large piece of equipment that was on that line that moved along. And so as soon as that was on, that piece of equipment was at that elbow height. And so it was achieving, for the most part, in theory, that ergonomic, goal of working at elbow height. Where the pitfall came in was they did not answer the second question, and that is, what equipment is needed or going to be used? So yes, we dropped the height. We'd accounted for the size and shape and height of the product that we were going to be manufacturing. However, in this instance, all of the components that attach to this product were going to be attached via suspension tooling. So as a result, what actually needed to happen was the line actually needed to go down even lower, because for the majority, we had really high instances of shoulder injuries because almost everybody was reaching overhead continuously for their suspension tooling, which was hanging above the product that they were manufacturing. So this is the base starting point, that we need to answer these questions if we are going to, with confidence, know we are starting at the right position. So we've identified what kind of work we're looking at. We've identified the height of our equipment and the height of our product. So when it comes to answering kind of where are we for our base height, that is kind of our big question. So our base height first comes from that precision, light to moderate, heavy work. And this makes really very good sense. It's not earth-shattering by any stretch of the imagination. So if we have precision work going on, obviously there's going to be a visual acuity that we are going to want to achieve. We're going to want to see that with our eyes. We're going to be dealing with very fine finger work. If we don't, we may increase our cycle times because there may be more mistakes. We can't get it into where we need to go because we can't see as well. This becomes a bit of a conversation when we start talking about the aging workforce as eyesight starts to diminish. If we don't have the right working height and precision work is what you do in your organization, then this can become a bit of a problem. So the answer, if we have precision work, we want to work slightly higher. This diagram on the left is actually out of the Canadian Standards Association's Z412 Office Ergonomic Standards. So the new standard that came out, it's an old standard that they revised and then sorry, it was a guideline. Let me get my facts straight. It was a guideline, and they revised it at the end of 1 year ago, actually, probably a bit now, and it is now a standard. And they actually go a bit above and beyond, and they do talk about design, they do talk about main material handling, and they do talk about some of the work anthropometrics that you want to try and achieve. So if you're interested in a kind of very well-rounded piece of documentation that is now a standard and is something we do need to look at enforcing in our companies, then this is a good one. So you can see that we kind of have 4 to 6 centimeters above elbow height is ideally what we're looking for when we're kind of getting into that precision work element. So yes, we know elbow height is 96 to 122 centimeters. And I do apologize. This is from the CSA standards. I am an inches girl through and through, so this presentation may flip-flop a bit, but if it's something I've written in there, it's typically going to be in inches. So precision, we want higher. We want that closer to our eyes so that we're not kind of bending down further, and we're able to achieve that high precision work with our fingertips very easily with the visual acuity. The elbow height, we want approximately at elbow height. We may want to go 5 to 10 centimeters below, depending on what kind of weight range we're looking at. So, 5 to 10 centimeters is a weight range that's been put and attributed to sorting mail. Most of our assembly line and manufacturing do require things to be slightly heavier than that, and that's where you get back to your 96 to 122 centimeters or your elbow height. Further from there, we then have our heavy work. And again, nothing mind-blowing. If we have heavy work happening, we need that working height to be slightly lower. The reason being, first off, we want better muscle recruitment. We want to be able to bend at the knees, kind of get under it, and then bring it up to elbow height if we're having to lift or push or pull or manually handle that item in any way, shape, or form. The other item is if we're having to exert downward force, if we have it slightly lower than elbow height. If you imagine if we had it at elbow height, then the muscle recruitment there is really going to be upper back, maybe arms, but not our largest muscle groups. So if we know we have that forceful exertion that we're required to do, then by dropping the working height, we can actually lean into it. We can use our entire body weight to our advantage. And that can be dropped anywhere from 20 to 40 centimeters below elbow height, which is quite a bit, again, depending on your working height. So the equation here that we're looking for is we need to first pick our base height based on the type of work that we're doing. And then from there, it is getting out your trusty tape measure and taking a measurement, a height measurement of the product that you're manufacturing. And if there's a range, we want to work with the range. We may need to talk to our production and our operations side to find out, well, what do we run the most? You may have a range of product that goes from 5 centimeters to 50 centimeters, but 95% of the time you run something in the 25 centimeter range. So don't get too caught up in the whole, oh my gosh, we run so many different things. Just take the conversation a step further and try and get a really practical idea. Because MSDs don't happen in a day, the day that we have kind of one day where we're working with slightly smaller product should not cause an MSD injury if 95% of our time is going to be spent working at ideal working heights. And then again, we want to take kind of a height measurement of the equipment. If you are required to use a screwdriver or a torque gun, we need to know that height as well, because that is where your hand is going to be, and that is going to be what is going to impact the posture in the shoulder or the back or the neck. Okay, so you subtract all of those from your base height, and that is what gives you your working height. So the big question, this is about assembly, this is about line work and adjustability on the line. And I said, and I started the conversation saying that we can't move an assembly line up and down for each individual worker. So if I had to pick one static height, whose am I picking? And answer that is happening currently is that most people pick somewhere in between that 5'6" to 5'10". If you're sitting at a desk right now, my guess is it is 29 to 30 inches high, because that is the demographic that desks are designed for. However, we will then have smaller individuals raising their shoulders up, and we have taller individuals bending down. So what is the answer? Well, as the graphic on the left shows, we can't cut people off at the knees. So, but we can raise smaller people up. So if we're going to get down to kind of how could I possibly achieve getting everybody at the right working height, the ideal answer is my base height is going to be engineered towards the tallest male's elbow height, because everybody else in that working population, I can raise up. I can't cut my tall men off, but I can take measures to raise my smaller employees up higher. And that's kind of one strategy that we can start looking at meeting those goals. Not to get too excited, at the end of the day, this is about ergonomics, and you really can't use the word ergonomics without understanding that adjustability always wins. So moving forward from this point on in the conversation, we've identified how we can achieve our working height measurement, what we want to design for. Now we have to determine, A, how far are you off that right now in your organization if you were to step onto your manufacturing floor, your plant floor, or your office floor for that matter. And B, is that a feasible option for you in your design practices? Because if either of those you answer no, we're not doing that currently, and B, or no, we're not, it's not feasible right now, then we know that the answer lies still in that word adjustability. It's just not going to be the physical assembly line type scenario that is adjusting. We need to find adjustability options elsewhere, because there is no way that we can provide static equipment and static design elements to a population that looks as diverse as ours. So when we're looking, for instance, at height adjustability, because that is a huge topic of conversation these days, and everyone in the office is talking about the sit-stand workstations. But if we are looking at, let's say, something along these lines, I will say that maybe my picture is not actually that well represented to the numbers I provided you. I apologize. But if we are looking, let's say, at individual workstations similar to this, that we are looking for adjustability, then the adjustable table is definitely an option. Again, this is something that you need to do your working height equation for. This is fine motor work. So they do have the person sitting, which actually is a good design element because it takes out the stability component of the work. They're not having to stabilize themselves. The chair is helping to stabilize them. So that is a good feature in this design. However, when you look at this, specifically that second gentleman in the row, those elbows are textbook 90 degrees. That working height is exactly at 90 at elbow. Sorry, getting muddled with my words. That working height is at exactly elbow height. But you can see with what they're doing, we're seeing the first gentleman who's bringing the work up higher than the work surface. We have the bending down to kind of do what they're doing. So they've achieved some good elements of design, but they have not achieved the working height. And in this scenario, for the cost, height adjustable tables might be something that we could look at. It could be the paddle, which is shown here if the weights are appropriate. It could be a crank, and it could be hydraulic. Where I have seen height adjustability attempts that have gone wrong, I've worked with a lot of companies that, after browbeating them for years, kind of said to me, okay, Alex, we get it. Adjustability is good. We went ahead and we did that. And the one client, they had inspection stations. And I went out and they showed me the inspection station, and it did indeed adjust in height. However, it started at 22 inches and ended at 38. So when you look at my range of heights here from 38 to 48, so this is 38 would be your small female's elbow height, 48 would be your large male's elbow height. 22 to 38 really was not a helpful height adjustability. And I'm not going to sugarcoat things by saying adjustability is cheap. It's not. So when we don't get it right, I knew they'd spent a ton of money doing this adjustability element, but they had completely missed the mark on their working height, what range they were going to start and end this at. So if you are looking at adjustability, and you do want to ensure that you can cover off your workforce demographic, then we are roughly looking at that 38 inches to 48 inch range. So we're looking A, that we need 10 inches of height adjustability, and B, they need to start and end at the right point, because essentially in this instance, the client was only accommodating work to the smallest female, and all of the lower adjustability was not even being used. Yes, it did adjust, but it just did not work well, because obviously no one needs to work at 22 inches, specifically for inspection. Maybe if it was manual material handling and offloading of big product, then it would have been a good one, but this was not the case. So that's the second point. Figure out your working heights, then realize where are your anthropometrics, and are your working heights going to fit into what we already know to be the elbow height measurements of at least North America. So these measurements are from, it's Caesar tables, or CAERAR tables, and they came out in 2002. And there are lots of anthropometric tables, and if you Google that, I'm sure you will find lots of information. The tables that I'm referring to, they are probably our newest set, and they are military-based project. So they cover probably the most diverse racial demographic that we've ever had in an anthropometric table, which is great, and makes it very well represented for North American culture. So if you're interested in that, I believe there are various places that have, it's a PDF, I'm going to be blunt, it's not a great copy that's online, but you can definitely find it free, and it's every table you want to talk about. We're just talking about elbow height currently, but it will have pretty much every height that you would ever want, and or breadth, shoulder breadth, anything. And you can look it up for the female tables from 5th to 95th, actually to 100th, as well as the male tables. Oh, my slide's not progressing. Try this way. There we go. So if we can't have a working height that is height adjustable, because maybe it's an assembly line, maybe the product is too large or heavy, or it just doesn't suit the physical purposes of what we need to do in order to build this item, then our next answer goes back to that cutting people off at the knees, or not cutting people off at the knees, shall we say, and how can we raise people up? And there are various options out there, and they work well. You know, low tech, simple solutions. The middle one is, you know, kind of, it shows two height adjustable kind of step platforms. I would say a lot of my clients in the meat processing industry obviously have a conveyor line. It's one height. The product is generally the same size, and they've done a fairly decent job at trying to make sure that the employees are working at a good height. And what they actually have is a similar system to this. They obviously have their safety railings on it because it is a 10-inch height range, but the standing platform will kind of, you can raise it up and then lock it back into a different kind of ratchet system type notched holder or support. I'm not probably describing that really well, and I apologize. But what I am saying is that it's doable. I've seen it done. I've seen it done well. And there are varying options that we can look at. So the first two are options of, hey, maybe we can try and create a platform that will raise our employees. The second one is maybe something we could do that we have a stationary surface, but we want to be able to raise it up or down to accommodate the stuff that's on top of the surface. So if you have, let's say, maybe packaging, and yes, you have days where, it's a big box and it brings the working height lower, but on other days we have smaller boxes. Well, this is kind of a platform that can sit on top of your table, and on those days where you have smaller product, you could still raise that product up to that elbow height. The key in that situation is that you need to make sure you're aware of what that base equation is and know that your adjustability is coming from on top rather than below the individual. So on top of the work surface rather than below the operator. But that is another option where we've implemented, specifically when we're dealing with some of the lighter components that we may manufacture, that is always an option that we may be able to raise the product up rather than the individual, which means we may start the working height a little bit lower so that those small females can still work at elbow height, and then we can raise it up for the taller males. So there are other things that we do in our work that go beyond just our elbow, our elbow height. So elbow height is definitely the focus of today's, because it is probably one of the most impactful design elements in any manufacturing or production type, design. But that's not to say that that's all we're going to have. So there are other things that we can look at to make sure that when we're looking to improve and make positive change in the name of ergonomics, that we can still go a little bit further and a little bit beyond the elbow height. So for instance, if you are looking at stature, overhead equipment is one that you would want to know someone's stature. And again, think about whose do we want. We can't cut people off at the knees. So we need to use, in that case, we need to use our tall male stature to ensure that no one is going to be hitting their head. I see this a lot in areas, specifically we get into that precision, or, we want to provide lighting and extra, lighting to enable our workers to better be able to perform their duties. And the lighting sometimes is too low. So for our taller individuals, they either sit, which wasn't designed for the workstation and therefore puts them in awkward postures, or they stoop to try and make sure that they're not hitting their head. So lighting is definitely one, specifically task lighting that we've dropped over the work surface, making sure that that's going to be at a height that, from a safety perspective, clears our stature height. And we also then go down to our eye height, which is our monitor height. And in today's day and age where tech is everywhere, monitors are also everywhere. We have our video display terminals, whether they be an actual computer terminal that we're looking at for, processing orders, or maybe it's a control panel for our CNC machines or our dies, presses, lathes, whichever we're talking about. But they're all coming with these monitor screens, and often we will see them at, not the best working heights for visual referencing. It doesn't take an ergonomist to know that if I'm referencing it with my eyes, I ideally would like that to be at eye height. So again, looking at eye height being the number that we're looking for. We always will use a shoulder height or knuckle height when we're talking about kind of good working ranges. We will drop down to knee height at an absolute, must, because our working height range between knuckle and shoulder is quite small, but we don't like to go down to knee height. Knee height means we know that there's bending. So we know that shoulder height is kind of our upper level for work. We don't like things to be above shoulder height. So if you did have that tooling suspension over your line or your workstation, then shoulder height is the measurement we're looking for. Now, again, the question is, whose shoulder height? If I put that suspension tooling at my tall male shoulder height, what are my smaller workers going to have to do? So it's just a tiny bit. People need to take the answers just 1 or 2 steps further in order to be able to answer the question to get a good ergonomic result. And in this case, shoulder height becomes your small females. Knuckle height becomes your tall males. Knee height becomes your tall males. You just need to think about who are we sacrificing if we design it in such a way. So in the case of looking at viewing solutions, unfortunately, this is another one where we really can't pick a static working height. It's not like the shoulder, the knee, the knuckle. We definitely really need to look at height adjustability because eye height is something that's going to vary depending on the worker. However, on the positive side of that, adjustability, when we're talking about video display terminals, the options are huge. What we can do with a video display terminal nowadays is astounding, and it's lovely, whether we're projecting, whether we're putting it on a height adjustable monitor arm. This is a whole unit that's actually attached to a run system that's embedded or attached to the wall, so it's out of the way, or attached to the side of, you know, a pillar or machinery, even if that too, but it allows the whole system to move up and down. So if they are, let's say, using this cutting laser bed on the right, then they can, if they're using, rather than using the static stationary option that is shown in the picture, they could use something like this that allows them to adjust. And if they have to input controls or program elements, quality information, then all of that could be done at ideal working heights. When we're looking at working heights, our range is 55 for our small female, 69 for our tall male. So oddly enough, this is one we often, I will see anyways, that because we want it out of the way for the employee, we will often raise these up higher. So if you have a lot of video display terminals that are attached to the program and function of the equipment or machinery that you have, I bet if you take a walk right now, you will see that a lot of them are actually higher than eye height. So, which is potentially okay if they're only referencing it a couple of times a day. Maybe it's a press that, you know, you set it up once and it goes for the next 4 days straight. In which case we know we're not really impacting negatively those neck postures to any huge degree. However, if we're constantly going back and forth, making adjustments, specifically if those control panels are touch screen, which a lot of them have moved to, those high terminals are causing now not just neck extension and neck problems, but they're now bringing in that shoulder as well. And these things sound kind of, you know, they're not the main process. They're just kind of subsidiary elements to our design and the workflow. But whether it be us causing an injury or sometimes what we often will get hung up on is the accommodation. Something now as simple as interacting with the video display terminal is now potentially a barrier for you to bring that person back to work. Because if I have a doctor's note or WSIB kind of report that's saying no repetitive right shoulder use or both shoulder use if it's bilateral, and we have a video display terminal that's at a static height and is up high like a lot of them are, then we are going to have a hard time convincing anyone that this is safe return to work. So something to think about, and it's my mind, I would say some of the easier elements as far as finding equipment and not having to create your own. They have lots of great options. Some of the other ones, if we have assembly line work, we often have, I'm not even saying necessarily assembly line work, we may have single cell operations happening, but again, they may happen at a static height and a variety of people are using them. And in this case, the parts that are supplied to them are often coming at various heights. This is usually not horribly designed for the operator of the machinery. Where we have challenges is our people that are actually supplying these racking systems. So anytime that we have kind of part or product delivery and we're using these types of racking systems, you know, we need to kind of do a bit of an evaluation. And the system, again, it's not it makes sense. It's not something that you're going to be going, oh my gosh, I can't believe she just said that. But it's generally not what we see put into practice. The parts are provided. The system is the same for everybody, and the heights are generally the same, but they maybe shouldn't be. If we have heavy items, we want those to be kind of at that elbow height. Depending how heavy, we actually may want them slightly lower, because that goes into the 20 to 40 centimeters that was up there in the CSA diagram that we talked about earlier. If we have, we definitely, by no stretch, do we ever want our heavy items to be on that top shelf. So we should do some ranking. We should rank our items in relation to how heavy are they, and then in relation to how frequently they're used. So your most frequent heavy items should be in the center. Your kind of lighter or rarely used items should be at that above shoulder height level, because typically if we're looking at the storage height levels and we go from that knuckle height to shoulder height, or even knee height to shoulder height, at the end of the day, when we're taking the smallest population for one of those measurements for shoulder height and the tallest population for the other, that is a very short distance. And that becomes challenging to get everything that we need to the operator. So looking at that, we just need to kind of be aware that we need to usually reorganize these kind of storage solutions so that the height that we're asking the people to load to and the height that we're asking people to retrieve from are representative, sorry, of the work we're asking our employees to do. So when we're dealing with low-level work, ergonomic guideline, a bit that you may want to kind of stick in your head. So we've talked about the 38 to 48 being elbow height. 21 inches is our tall male's kind of knuckle height. So we know, and if you want to stand or even sit, if you want to look at where your knuckle height is, if you were to put anything at your knuckle height, then you could pick it up without moving your torso. As soon as you drop down below knuckle height, we then sacrifice posture. So we start to get that bend. So on a design element, if we know 21 inches is our tall male's knuckle height, and then we accommodate that, then no one else will definitely have to bend, because he's going to have kind of the lowest knuckle height we have. So that is one measurement that we can look at. And yes, again, our adjustability options, we have the GIF kind of going off to the right that is showing a variety of options for height adjustability that could be implemented. And if those elements or pieces that they're showing in the video are something that looks like something you have on your floor, then those are definitely great solutions. The height adjustable carts, I have to say, I love height adjustable carts. I also love your spring-loaded or height adjustable pallet risers. Really great low-tech innovation to solve a really, big problem in most organizations. However, if that's not feasible, then we can go even lower tech and stacking pallets so that the working height is kind of improved to above that 21 inches is also another option you could do. So it's not to say that if we can't do adjustability that we just give up and that we can't move forward from there. There are other solutions. Maybe we build a stand because we don't like stacking pallets, because we need the pallets for something else, or we feel that's health and safety issues that could topple. But the idea is that we elevate anything that we're going to have to bend down to at least above that 21 inches mark, so that we're able to improve those working heights. We then have our high level work. So you can see this gentleman here, that is the first one is a video display terminal that he's having to access, and look at the neck and shoulder postures that are required there. And that is not untypical, if that's awful grammar, but that is something we see all the time. We want it kind of out of the way, so we put it up here, but the employee actually required to access it. And sometimes it's not because of the design. We didn't intend them to, but as machinery ages, as systems get glitches, as things do not move well, we will often hear as we, interview the operators that, oh no, I use this all the time, every day, all day, every 5 minutes, because there's always issues on the line that they're having to circumvent. So definitely this is one where, again, you can see that the tooling that they have on the left-hand side is too high. If he doesn't look to be a very small individual, but if he's almost at, 70 degrees at shoulder postures there, then our smaller employees are going to be quite a bit higher. The other thing you can kind of imagine, now I can't really see what parts are going on here, but the working height looks to be low. Now that could be a positive thing because the size of the fixture looks to be a little bit higher, so it may come up to his elbow height. But the design elements here, just looking off the bat, there's some questions and there's some full out hard stop. No, this is not good. So the height for high level work is our small female's shoulder height. And that is 49.6. So if we said 50, you'd be okay. 49.6 is actually the shoulder height for small females. If we can't design it down or we want it to be higher up, then maybe suspension or, a slight counter lever needs to be implemented as we're showing on the right to allow that element, tool, control monitor, whatever it is, to be brought down to a working height that's going to be workable for the end user. At the end of the day, we want to try and avoid these pitfalls. And if we're trying to avoid, the back, the shoulder, the neck, the wrist issues that we often will see, then we want to really go back to the anthropometric measurements that we know. We know we don't want people working above shoulder height. So the question becomes, how do I make sure no one has to work above shoulder height? If small females aren't working above shoulder height, then the rest of our population shouldn't be either. So then that becomes our base height. We then may need to do some slight calculations based on the equipment and tooling that we're using or how we're using it, which is maybe something we haven't talked about, but that would be a whole different conversation. And adjust accordingly. So this information's out there. You can, by all means, download the Caesar tables. However, the answer usually is a lot more findable. If you're looking for small female shoulder height, that would be what I would Google because it's out there. Or you can always give us a call. Send us an email. We will tell you what your design parameters are within a very, very short period of time. This is something we live, eat, and breathe. And everyone's always amazed that I can remember these numbers. And I'm like, when you deal with them for 8 hours a day, it's easy to remember them. So avoid your pitfalls. Know what your working height, your base working height should be, whether it's based on the type of work you're doing. Do your calculation, take your tape measure out onto the floor, go to the engineering team, whoever you need to get this data from, but start collecting what's our tool sizing, what's our product sizing, and then try and work through, based on our base working height and subtracting those two elements, what is our actual working height that we want. And can we achieve that? And if we can't, then going forward, we know ideally we actually want to have the design designed for a taller individual. And then we know from an operations, from a health and safety, from an ergonomics perspective, those smaller individuals, we now have to start thinking outside of the box for opportunities to raise those individuals up. And that is how, without putting adjustability into an assembly line or into, let's say, the actual work surface, how we can still get good ergonomic practice without having everything being adjustable. Unfortunately, I cannot tell you that you're not going to have the word adjustability in your design somewhere. As I said, demographic is too great, our size range is too great, and so therefore we do need to be considering those smaller, those taller individuals. What we do know, and it's getting better because of the adjustability conversation that's been improving, but what we do know is typically when you are opening up a catalog, when we first hit the design floor, the numbers that are being bandied about are going to be your average adult, that 5'6" for your average female, 5'10" for your average male, kind of range. And it is comforting to know that, oh, it's, it's only a few inches, but it is limiting from a design perspective, and in all likelihood will lead you down to MSDs and harder return to work programs when you kind of move forward. So I encourage anyone, if you have questions, please include them either in the questions or the chat bar. Typically what we do, just to help with flow, is we will collect the questions and we will send out a handout, shall I say, that kind of has what the questions are and any responses that we can have. And we will send it to all the attendees and registrants of today's webinar so that everyone can benefit from the answer of the question. So if you could do those, Julie is on. Some of the more simple questions we may answer right away, but typically we'll just hold back and we will send out an email afterwards with those answers available to you as well. Specifically for this type of thing, you can have that as reference. Our webinars, for those of you that are new, are always videoed. So anytime you will get a recording link to our YouTube channel, and you can go back and reference these whenever you want, because there are some really good anthropometric data in there that, you may not remember in 2 weeks. So if you just go back and kind of swing through, you'll be able to find your elbow height range, your monitor height range, or your low level or shoulder level kind of working maximums or minimums, rather than kind of search or scour the internet for the information you're looking for. I really appreciate your time today. I know it's getting close to the holidays and everyone's time is becoming more and more valuable. So thank you very much for being with us today. In January on the 24th, we will be having the low-hanging fruit of ergonomics, which will be a great topic and I think something that everyone can get something out of. So I definitely encourage you to register for that one. And I hope you all have the very best break and happy holidays and have some very fun, relaxing, safe time with your friends and family. You guys take care and we'll talk to you soon. Thank you.